Hello, this is Sean Mullery from Electronic Engineering at IT Sligo, and in this short lesson what we're going to do is we're going to look at how to set up some of the digital I/O port pins as inputs. We're then going to set up the port A, the full of port A, as all inputs, and we're going to set up all of port B as outputs, and that is going to allow us to then write a program where we take whatever comes in from port A and put it out on port B. Okay, it's called echoing the pins. And then we're going to show that in simulation, so we're going to show that operating. So what I want you to do this is the following. Firstly, go to the user C file, which is where we like to kind of compartmentalize the sections where we initialize the port pins. And you've already seen how to set up a port as all outputs, and you do that by just putting 0 or assigning 0, sorry, not to port B but to tris B. Tris B like that. Now you could just say tris B equals or is assigned 0 rather than going 0x00, but I just think it's a little bit more readable if we do it that way. And what I'm going to do is I'm going to put a little comment after it that shows all the 8 zeros that are going out to it, so that it's quite clear what we're putting to that. And no harm to just write a little comment as well that says port B set up as all outputs. Okay. Now, to be honest, you know, that instruction becomes so commonplace that you really don't need a comment after it, but it's probably no harm for the beginning to just get used to making comments like that. Now, to set up a port as an input, which is the whole point of this exercise, what we do is we do the opposite. We set it all up as all ones. Now the hex value for that is FF, okay, where each hex digit of F is 4 ones, so we need 2 of them in order to make 8 ones. So that's going to come out as follows. One, 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 and we'll just write a little comment. Okay, like that. Now, there's one small extra thing I'm going to get you to do, and I don't want you to worry too much about what I'm doing here because it's a little bit of an advanced topic for the moment. But I want you to go to configuration bits. Now, to find configuration bits, we go to the Windows menu. Okay, go to Pick Memory Views and go to Configuration Bits. You click on that. Okay. In configuration bits, what I want you to do is I want you to select the EC section for the first the first set of options there. Okay, it's the EC. I'll just set that again. EC. Okay, or you can also look over here. You'll see it. It's what we're. Apologies, that's my thing keeps coming out of the side. It's setting it up as ECIO, which is port IO functions, or A6. Now, what this basically means is that some of the bits in the A port are multi-purpose. Well, most of the bits are multi-purpose, but in particular, these bits can be set up for oscillator use as well. If we want to use them as digital I/O, this configuration bit has to be set in this way. That also means that if we were to put it on an actual chip, we have to set up our oscillator in a certain way for our crystal frequency. So it may not be something that we would do in the long run, but for the moment, just for this exercise, I want you to do that. Now, when you've changed that setting, I want you to hit the Generate Source Code output. And it does that, and I want you to select all of that text up as far as config1, copy that, go to your configurationbits.c file over here on the left, click on that. Now I already have it pasted in, but I'll just paste it in again just to show it being done. Okay, now this is just configuring the pick slightly different from the default that it was set to. So it sets up other things as well, such as watchdog timers and so on. Again, they're advanced topics. We're not going to look at those just yet. But for the minute, I just want to set that, or otherwise some of our port pins on the A port will not work correctly for what we want to do in this particular example. Okay. So once you have that done, what we're going to do is we're going to write a very, very simple program here, within our while one, what we're going to do is we're going to take everything from port A and put it into port B. So that involves the following. Okay, so port B is assigned port A, as simple as that. Now you could of course assign the value of port A into a variable and then put it from the variable back to port B. But for the minute we're just going to do this. It's the simplest mechanism for doing it. Because this is in the while one, it's going to continually check what's on port A and put it into port B, which means that any modification that we make as we go should appear on port B. Okay, so I'm going to save that there at that, and I'm going to set the debug going. Now, when the debug is actually running on the simulator, you need to set up your I/O port pins to show both all 8 of the port A and all 8 of port B, which I already have set up. Okay, you can see them here. You can see RA down to RA0 down to RA7. I'll just move that up there a little bit, and you can see RB0 to RB7. To select a new pin, you just click in an ordinary way and then find the pin that you're looking for within the list. So for instance, RA0 would be there, and you just keep selecting them. I've already done it, and what you notice here, and this is worthwhile checking on your own machine just to make sure it's working, check the mode. All of RA is set to D-in, which is digital input, and all of RB is set to digital output. Okay, so what I'll do is I'll change one of the values of RA. So I'll change that one, and you should see the corresponding one in RB change. And indeed it does, it's changed there. So I've changed RA1 and RB1 has changed as well. We'll try RA5. And again, we see that RB5 has changed. So this is just echoing whatever comes in, it comes out again as well. Okay, so I want you to get that up and running for yourself so that you see it working. Okay.